In 1977, humanity launched a pioneer into the unknown. Voyager 1, a small, resilient craft. It has traveled over 164 astronomical units from Earth, a distance so vast it challenges our understanding of scale. 1 astronomical unit is the distance from Earth to the Sun. Voyager continues to cruise at 17 kilometers per second. To survive, it now operates in a strict minimalist mode, conserving its final, dwindling power. The heart of Voyager 1, its radioisotope thermoelectric generators, is slowly fading. With every passing year, the probe loses 4 watts of power. NASA engineers expect the final scientific operations to conclude between 2027 and 2030. Once the power drops below the critical threshold, the transmission will cease. In 2024, Voyager 1 faced its most critical challenge, a catastrophic memory glitch in its flight data system. The probe, built with 1970s technology, began sending back unintelligible binary data. This became a landmark case study in legacy engineering. Over 15 billion miles away, engineers at NASA successfully pushed a remote software patch to bypass the corrupted memory sectors. This unprecedented operation proved that even after nearly 50 years, we can still communicate with our interstellar ambassadors. Voyager 1's power source is fading. With a steady decline of about 4 watts every year, NASA engineers are forced to make impossible choices to preserve the probe's life. The mission has become a race against entropy. Every watt saved is a chance to keep humanity's voice reaching out from the void. Voyager 1 is now on a permanent escape trajectory. It has left the pull of our solar system, becoming a true galactic drifter that will never return home. The probe is locked on a path toward the constellation Ophiuchus, traveling at 38,000 miles per hour. In over 10 trillion years, Voyager 1 faces 2 primary risks: high-velocity micrometeoroid impacts and the potential pull of an unknown star. While these impacts are possible, the sheer scale of the galaxy works in the probe's favor. Space is nearly empty, meaning the probability of a collision is infinitesimal. In the absence of air resistance or erosion, the probe becomes an artifact of deep time. It will continue its journey as a nearly indestructible messenger. Astrophysicists view Voyager 1 not merely as a machine, but as our greatest contribution to deep time. It is a silent monument to human curiosity, casting its existence into the vast, dark ocean of the galaxy. It serves as an enduring artifact, waiting in the silence for whatever might eventually find it. Communicating with a probe billions of miles away is a feat of modern engineering, yet the signal is fading. We rely on the Deep Space Network, a global array of giant antennas designed to catch the faintest echoes from the void. Voyager 1 is not merely a traveler. It is an explorer on a one-way trip. There is a common myth that it might one day return, but the physics of its escape trajectory dictate otherwise. By reaching solar escape velocity, Voyager has permanently broken free from the sun's gravitational tether. It is a lonely, silent ambassador, drifting forever into the interstellar medium. Even when the radio signals finally cease, the legacy of Voyager 1 endures. Voyager 1 operates on a dwindling fuel supply. The fragility of the mission was highlighted in 2024 when a memory chip failure began producing corrupted data. In a feat of extreme engineering, NASA mission controllers performed remote surgery, successfully patching the spacecraft's memory banks from over 16 billion miles away. This constant maintenance ensures that Voyager remains our eyes and ears in the interstellar medium. The Voyager 1 mission is approaching a profound shift. As the onboard power generators continue to decay, we reach a point where the last scientific instruments must be powered down. At this milestone, the spacecraft will no longer be an active scientific explorer. Instead, it will transform into a permanent, passive monument, drifting through the interstellar medium. Floating in the near-perfect vacuum of space, Voyager 1 will circle the galactic center, serving as a silent, indestructible record of the civilization that launched it. The probe is now on a permanent, chaotic orbit around the center of our Milky Way. Space is incomprehensibly empty, making the probability of a collision with a star or planet statistically near zero. Voyager 1 will drift for trillions of years. It will likely survive until the eventual decay of its physical structure. At the heart of this craft lies the golden record, a tangible snapshot of our world. Voyager 1 has fundamentally shaped our perspective on the great beyond. Voyager 1 is our message in a bottle. As it drifts into the next 10 trillion years, it carries the heartbeat of Earth. If an advanced civilization finds Voyager 1 in the distant future, what will they conclude about the species that built it? Perhaps they will see not our conflicts, but our insatiable curiosity. Voyager 1 is our most enduring legacy, a story of humanity that refuses to be forgotten.